Hello, I want to go over a quick sheet here of properties of logarithms, and for our course this is corresponding to some guided notes for section 3.4. Alright, so we just found this and thought it might be nice for you to see some properties as they're all listed together. So we're going to talk about properties of logarithms. So let's get started. Okay, so to begin with, we have a rule that says that the log base b of 1 is always equal to 0. Okay, so if you take the log base 3 of 1, it's 0, and the log base 7 of 0. Okay, and you can verify that with the calculator if you are so inclined. Okay, next rule is if you have log base b of b, it's going to be 1. So like if we said log base b of 2, and I ask you to evaluate that, that's always going to be a 1. Okay, all right, next property, b to the log of base b of m equals m. Okay, so maybe you want to notice here your bases are the same, and if that happens, whatever we're taking the log of here is going to be your answer. So over here to the left, if my base is 5 in here, I want this to be 5 to the log base 5 at 25, and my answer is going to be 25. Okay, so the next one here, we've got log base 2 of 2 to the 6th is 6. So what happens is your rule, log base b of b to some power m is going to equal m. Okay, all right, next up are maybe some of the rules you're a little more remembering from an Algebra 2 course. Log base b of mn is what we're going to start with. Log base b of mn. Okay, so this is a product, so that means m and n are multiplied together. Okay, and that's going to give us log base b of m plus the log base b of n. Okay, so you can take a value like 8, think of that as 2 times 4, and you can separate that into the sum of two logarithms. Okay, all right, next up, quotient. Quotient means divide. Okay, so then if you have log base b of m over n, it's going to turn into log base b of m minus log base b of n. So when we divide, it turns into a subtract. And if you think about your exponent rules, that's exactly what we've got going on here. All right, so let's see an example. Log of 2 over 3, or 2 divided by 3. Okay, so you're going to take the log of the top, so 2, minus log of the bottom, which is 3. Okay, and you've expanded it as a difference of two logarithms. Okay, next one, we have a power. So log base b of m, and it's raised to the n power. Okay, if you simplify, you're going to pull that exponent to the front, so n times the log base b of m. Okay, so the power in the front ends up out here into the front of multiplying with the logarithm. Okay, next up, we have log base b of m equals log base b of n. Okay, when that happens, you have log in the same base, well then m equals n. All right, so here log base 2 of x equals log base 2 of 5, so we conclude that x equals 5. All right, one more for your properties. Okay, change of base is probably one of my favorites. Okay, I tend to use that one quite a bit. So it just says that if you have a log with any base of a, okay, you take the log of that number a divided by the log of that base. Okay, so the base down here. So that way you can convert any logarithm into a base 10, so you can use your calculator to evaluate. Okay. Okay, so an example could be something like log base 2 of 8 equals log 8 divided by log 2, and in that fashion you could use your calculator to come up with a decimal answer as needed. Okay, so again, this is just kind of a nice quick examples with the property and an example to go with. Okay, if we go on over here to your next page, okay, and again, if you are okay with these, you can stop your video at any time, but I'll go through page 2 of your guided notes, a couple of examples here. All right, so this first part says evaluate or write the expression as a single logarithm. Okay, so if we have like log base 2 of 14 minus log base 2 of 7, okay, that subtract tells you we want to do a divide. So it comes out log base 2, of 14 over 7. Okay, and if you simplify, you can say log base 2 of 2. Oh, and if you flip over on the back, you'll see that that also is one of our properties. So that comes out to be just 1. Okay, so that was kind of a nice one. All right, let's take a look at this next one. We have all base 7s. I'm going down here to number 4. So as a single log, we could say log base 7 of 3x, and that's going to be over 9x plus log base 7 of 6y. Okay, so then we could simplify over here a little bit. So this becomes log base 7 of, see, we can reduce 1/3. Did I copy that? I guess I did. 6y. And then if it's a plus, it's going to say multiply by 6y. So in the end, we end up here at log base 7 of 2y. Final answer, because you're simplifying in there. Okay. All right, let's grab this number 5 right here. Okay, so we have a number in the front that's going to come up as an exponent. So this is going to become log base 2 of x to the 5th minus number in the front again, come up as an exponent, log base 2 of y to the 2nd. Okay, so subtract means divide with our properties. So log base 2 of x to the 5th over y to the 2nd. Okay, and that's your final answer. All right, let's see what else here. On down the page, again, it's changing the directions. So this one is expand, simplify if possible. All right, so this one we want to take it and use the rules and break it out. So first here, we're going to have log base 3 of 8, and I'm going to say plus log base 3 of x to the 2nd plus log base 3 of y. Okay, now if you're thinking with me, I'm thinking, oh, I could have done something else in the process. I have an exponent up here, so I could bring it out front. So I could say log base 3 of 8 plus 2 log base 3 of x plus log base 3 of y. All right, let's see what else we've got. How about this one right here below? We could say log, and we've got an x squared. So let's pull that 2 out front. Okay, plus log, y, but it's a 3, put it out front. And then minus, I'll catch this 4 here first, 4 log z. Okay, I think that's looking pretty fantastic. Down at the bottom, you're just doing a little bit of evaluate without a calculator. Okay, so again, you're just practicing rules. Like this first one, log, remember this is base 10 of 10 to the 2nd. Well, that's just 2. Or like log base 9 of 9 to the 11th is 11. 64 is like 4 to the 3rd, if you think about that. So that's like saying log base 4 of 4 to the 3rd. So that part's just 3. So 11 minus 3 is 8. Okay, and so forth. Okay, I've got to run. I've got a class coming in here in just a minute. But I hope this was a little bit helpful for you with properties of logarithms. And I hope you have a fantastic day and enjoy your properties.